Hi everybody, in this video today we're going to be doing the first couple of examples on the lesson on falling objects. So we've been dealing with the kinematic equations and we're going to continue to deal with those kinematic equations. It's just now we're talking about when things are falling. So a side note up here, the force of gravity on Earth is 1g. You've maybe heard that before, like how many g's are you experiencing? And 1g is 9.8 kilogram meters per second squared. I mention that because acceleration due to gravity is 9.8 meters per second squared, and so 1g is just like one of those amounts per kilogram. Okay, let's go ahead and look at what I have written here. Objects in free fall accelerate towards the Earth's surface downward at 9.8 meters per second squared. If objects start and end at the same vertical position, they will make a symmetric parabola on their distance-time graph, and I drew that over here. Because this is symmetrical, initial velocity and final velocity are equal in magnitude in opposite direction. So we can see I drew these blue velocity arrows in because velocity is the slope of the distance time graph. So this velocity and this velocity are the same. They're going to be the same magnitude, just one's going up, one's going down. That means if you throw something upward with a certain velocity, when it lands, it will have that same velocity. In addition, because the graph is symmetrical, the amount of time it takes to go up will be the same as the amount of time it takes to go down. Okay, let's talk a little bit more about this. Objects' gravitational acceleration to the Earth will cause objects to accelerate towards the Earth's center downwards at 9.8 meters per second squared. We call that the acceleration due to gravity. So I'm abbreviating that A sub g. The acceleration due to gravity is 9.8 meters per second squared. We typically use a negative showing that it's going downwards. Okay, let's look at a couple of examples. So in this first example, a rock falls from the top of a cliff and hits the ground 4.2 seconds later. How high is the cliff? Here's my diagram, here's my cliff, here's my rock. I know from my problem that t is 4.2 seconds. I know because I just talked about it, the acceleration due to gravity is 9.8 meters per second squared, and I have a bunch of equations to choose from. I'm going to choose this equation with some changes. So let me take a minute to go through the changes. One thing is, in this equation, they have x's, but we could also use that same equation for y's. So we could talk about the final y and the initial y and the velocity in the y direction and 1/2 at squared. So I can use the same thing, even though it's listed for x's, I can use it for y's. And that's what I'm going to do. One more thing I can do is I can subtract this initial y from both sides, and that's going to give me delta y. So I'm going to rewrite this equation with a delta y. So it's the same equation, I just changed the y's, x to y, and I subtracted it, but it's the same exact equation. And so we're trying to find how high is the cliff. We're trying to solve for y. Its initial velocity when it falls, it is not thrown, it just rolls off and falls off. And so its initial velocity is 0. So if I plug in a 0 here, that's going to give me 0, and that's going to drop off that whole section of that equation. So really all I have is 1/2 at squared. And my a is my acceleration due to gravity, 9.8 meters per second squared. And my time is 4.2 seconds, and I do need to square that seconds squared, and I do need to square that as well. So take a second with your calculator, do this calculation, and see what you come up with. And when I multiplied this out, I got negative 86.4 meters. And we have to think about, why is that negative? Well, it's negative because the change in y is negative. It drops 86.4 meters. So the change in y is negative, and that does make sense. So that means the height, which our initial question was asking about the height, so our height is 86.4 meters. Okay, let's go on to the next question. Okay, how long will it take a water balloon to fall from a 17-story building? One story is approximately 3 meters. So let's take a second. If it's 17 stories and 3 meters per story, that's about 51 meters. So that is the height that we're dealing with, is 51 meters. I'm using the same equation I had before, but once again I've changed it to y and I changed it to delta by subtracting it over. Once again it is falling. It is not thrown, so my initial velocity again is 0. So now when I plug in my numbers, I also have some different things. This time my change in y is 51 meters, and I can say it went down 51 meters. And the acceleration due to gravity is negative 9.8 meters per second squared, and the time is the question we are asking for. I'm going to go ahead and start plugging this into my calculator and see what I get here. So I know that this is negative 4.9 meters per second squared, and then I'm solving for time. So I need to divide 51 divided by negative 4.9, actually negative 51 divided by 4.9, and that comes out to be 10.4 seconds squared, because when I divided these, the meters canceled and I came with a second squared up on the top. So 10.4 seconds squared is the time squared, but I'm not looking for squared, right? I need to take the square root of each side. So go ahead and do that on your calculator and see what you get. And I'm getting 3.2 seconds. I'm going to make a note in the margin, and you should make this note too, that this equation will simplify to this equation when your initial velocity is 0. So this is just a shorter version. You can use that same one. This top one is the one that's given to you on your AP equation sheet. This is a little bit simplified. So we can use that simplified version, and we've already used it a couple of times. So for this next question, a punter can punt a ball straight up 36 meters high. How long is the football in the air? Its starting velocity, not its starting velocity, its top velocity will be 0. So if I draw out how this is going to work, this person punts the football, and it does have an initial velocity, but when it gets to the top, its velocity is 0. And so I maybe can use just half of the parabola to figure this out, because if I can figure out one half of it, then I just multiply it by 2 to get the other half. So that's what I'm going to do. The delta x is 36 meters. The acceleration due to gravity is negative 9.8 meters per second squared, and we are looking for the time once again. So I'm going to take that 36 meters, and when I multiply this, I get a negative 4.9 meters per second squared. And I'm going to divide that out, and it's going to give me t squared. So take a second to divide that. And I'm getting t squared is 7.35 seconds squared. And so once again, if I take the square root of both sides, then that will give me t. So do that on your calculator. And that when I do that on my calculator, I get 2.7 seconds. Now, that is only half of it. That's only from the top to the bottom like that. I need to find the other half. So I basically need to take this number and multiply it times 2. And when I do that, I get 5.4 seconds. 5.4 seconds is my answer. Because it took 2.7 to get to the top, and it took another 2.7 to get to the bottom. I think we're going to stop this video there and then pick up the next video on the next question.